that's part 4, and I might actually have time to finish part 5. Okay, you've got to read these things. It's really important because I will not be able to cover. Python is a huge programming language. Right? I still learn things about Python every so often now. Right? To really get the most out of this semester, please read the things I send you and watch the things I send you. If you do, by the end of the semester, you will be a very good Python programmer. Okay? In this notebook, we're talking about functions. Again, there's more than I can cover in a single lecture on this. Go to these links here. So how are functions used in programming? Well, there's a saying that if you have to copy and paste the same code more than once, if you're writing the same code more than once, you're not programming right. And it's true. If you're doing the same task more than once, write a function for it. Write a function that you can just call that little bit of function to do what you want over and over again whenever you want to. So for example, we might be printing from different types of lists, and we want to print the items in that list over and over again. Here's just one list, but what if we had like 30 lists? We would not want to type this for loop 30 times, right? We would want to take this concept and put it into a block of code that we can just call over and over again. And we do that with a function. Okay, so let's see. There is a typo here. We need to enter into our function. So the way that we instantiate a function is with the def argument. Okay. So, oh no, it's not a typo. I'm sorry. There's too much code on the screen. So we have these two lists, right? And I define a function with the def keyword. Def space, and then I make my function name. Function name should be lowercase, and we're going to pass into this function something called items. Right? We're assuming that it's going to be a list right now, right? And then for each item in items, we want to print. And then at the very end, we make a print new line. Notice that this new line print is after the code block for the for loop, right? We're no longer those white spaces in. Also notice that the code block described by the function is here, right? So all of this here, all of that is inside of this definitions. Those are in the scope, I suppose, of this function. So once we make this, printing these lists is as easy as calling the function. So I just copy this code, paste, and run. We see that we get these print statements, right? Just by calling that function, that custom function we made, we get this list. Now, I'm kind of annoyed that we didn't include this in our print statement, right? Like, there's no reason why we shouldn't be able to put this nice code line there and then like put a title up top, right? But the titles are different based on the list, right? And there's no simple way of converting a variable name into a string. So what I decided to do is to add something called keyword arguments. So functions they don't have to take arguments, but if you place some argument in your function definition without an equal sign next to it, it has to be there, right? Now, after you place all of those things that have to be included into your function, you can then, and only after those, place in what are called keyword arguments. So keyword arguments are variables assigned by default to be some value. So I'm going to say that my title of my print is by default set to my list. And if I want to, when I call the function, I can change this keyword to be whatever I want. And then also I have this other default value set to false called show numbers. So let's go down the line here and see what's happening. So white space, I'm inside of my function definition. I make my title equal to this string. Notice the .title method, that's doing something to the string, right? It's a method on whatever this is passed in. Then I do my little line trick here to get the appropriate size dashed lines across the screen. And I print those out. So basically all this is doing is taking whatever this is assigned to, which by default is my list, and then underneath that have a bunch of dashes. Then if this flag, this keyword argument, but when it's Boolean, people call it flags sometimes. If this keyword argument is true, so if true, that means we're going to go into this block of code here, right? So it's set by default equal to false, but if it's true, we go down here. Okay, and I have like a little comment for you. Like if this is true, we use the enumerate function to number the items that we were printing out. So what's happening here? Enumerate does what? It gets the index and the item from the list, right? So index item, and then I print index plus 1 and then the item. Why? Because I don't want to see zeros as like the label for something. Python indexing starts at 0. So I just add a plus 1 so that my labeling starts at 1. Now, if this is false, which by default it is, if this if statement's false, we go to the else. So this is by default what will happen, and it's just simply for items and items, print item, just as before. And then we have, after the if else statement exits, we print a new line. So let's see what happens when we make this definition. Oh, just gonna copy all this. Let's see what happens now. So notice this is print items, and I now set my title equal to my first list, right? It's by default equal to that, but I'm setting it now equal to this. And then the next line, I have print items, my second list. This is the title I give it. And then show numbers equals to true, okay? So notice what happens here. Look at the title, my first list, right? Notice that when I passed it in, I had lowercase letters beginning at each word. Well, I took care of that by calling the title method on each of those, okay? And then for this first function call here, I specified my title to be my first list, and I didn't say anything about numbering it. Show numbers was false, which means that this is what's executed to print. However, in the next line, I say show numbers is true, which means this will be executed, okay? It's kind of nice. It's starting to look like decent output, right? Numbering the things, has a nice title. But what happens if we write this code and we share it with a team, and we don't, like, they use the code and they use this function in a way it shouldn't be used. For example, they try to pass in for items a string instead of a list, right? We don't want that. So the way that we deal with this is with exceptions or error catching. Now, this is not how you will program when you are doing just straight up machine learning on your own, trying to get things done. This is something that I have to tell you about if you ever deploy your code, is putting in checks for user error, right? It's very important. I'm not even going to require this on your GitHub account for your final project, but if you really want to impress me, do include this. Because that means if you have appropriate error catching for the functions you write, that means that your code is shareable and you can distribute it, which your employers, which they will probably see your GitHub account, will definitely appreciate, right? Also, when we go and we learn to use the libraries that Python has that are built in, if you read the documentation for the code, if you read the source code, you will see this stuff everywhere. So you have to get used to just like seeing it and understanding what's happening. So basically what this is doing is, so if it is not the case that the type of my items, this is a Python built-in function type, if not type is list, what is it saying? This is a convoluted way of checking if the negation of the type of this object is a list. Negations are either one thing or another, right? So if we pass in a string, the type will be string, and not string list, it'll happen. Okay. I'm going to clean this up later. I just wanted to show you that this is how you do it. So you basically have a conditional check, and then you type in raise, and then this will be a type error. Okay. And at the top of this notebook, there's a link to working with this kind of stuff, a very detailed link about it. And then I check to see if it's a list, and then I make sure that this here is a string. And then I make sure that this is a bool, okay? So they can't mess up my keywords either, right? So now if I run this, I just copy that and I try to pass in the string hello. I should get what? I should get this one, right? Notice what it prints out. Items argument must be of type list, right? That's what I said. Or no, it's this one. Items argument must be of type list. Or maybe if I wanted to be like, that. I just type in warning, exclamation mark. Can I run that? It tells me what my type error is. It tells me the type of error too, type error. There's other types of error and exception handling that are in the link that I provided. Again, don't be overwhelmed by this right now. This is just something that I need to show you for when you're reading other people's code, or if you ever are deploying code with your profession. Okay. Next up, the last step of any good programming writing. You write a function and you're getting ready to distribute it. It has error checks, but you're not done yet. You have to write documentation. In Python, these are called docstrings. And there's a link to writing good Pythonic documentation in this notebook. And it's very important if you're sharing code to have, if you're writing professional code, you have to document your code, especially in an open source environment when people are constantly reading each other's code, right? This is how you should do it, and this is how it's done in a professional manner. If you do this with all of your code, and that's what I see at the end of the semester, I will be very happy. Right? So what is a docstring? Well, when you define your function, you put in, so 3 double quotes to indicate that you're entering into a docstring, okay? And what is this docstring doing? Well, it is a brief description of what the method is or the function is and what it's used for. In this case, prints the elements and items to the user. That's what it does, right? Also, it should list any arguments, both required and optional, that are passed, including keyword arguments. So passed in, that's a typo. So for example, what do I pass in? Items. Well, the parameters of my function, items is of type list. That's what it should be. The list of elements to be printed to the user. Next up is a keyword argument, my title. What type is it? It's a string and it's optional. The title to appear above the elements and items. Default, my list. Okay, do you see what's happening? Like if someone stumbles across this code, they'll be able to read this. Show numbers, Boolean, optional, right? Raises, type errors, returns nothing. Okay. Now, what's more, and what's really professional about this, so if I just copy all this, and then I run it right here. Okay. So this is in my code cell now. Look right here. I'm calling the help function on the function that I just made. Let's see what it does. Look what help function returns. It returns your docstring, right? That's exactly how the code we saw earlier worked, right? When we wanted help with, like, for example, if we wanted help on the zip function, look at what it's doing. It's telling us exactly what's going on. When you write your own docstrings, you are practicing what it means to be a serious Python developer or data scientist or someone in that field. You're practicing it, and I think it's the best type of practice, even though you're just now learning. And it's really simple. Just follow these bullet points. In fact, like literally just like copy this, paste it into the function that you're writing, and then change it to fit the function that you wrote. That's it. Okay, so far we have dealt with functions that return nothing, but useful functions typically return something. And this is done with the return statement. So the return statement serves two purposes. It immediately terminates the function and passes execution back to the caller. It also provides a mechanism by which the function can pass data back to the caller, the person running the function. So for example, I'm going to write the sign function, which you pass in a numeric value. If that value is greater than 0, it returns a +1. Otherwise, it returns a -1. This sign function in the future will be one of our activation functions for neural networks, this exact same type of function. Notice I already put my docstring in. All I did was copy it from above, paste, and then started rewriting it. That's all I did. I have a razor, which is this is much clearer to me than the one that I had above. I just wanted to show you that there's different types that you might see when you're reading other people's code. I like this one a lot. If the type of my input is not in this list, that's kind of clear, right? If the type is not float or int, then raise an error, right? And then, okay, so if this passes, then it checks, is it greater than or equal to 0? Returns 1. Function exits. As soon as return is called, the function exits. So if this is true, this happens, done. If this is not true, this is never seen. It goes this and it returns -1. Okay. So let's go ahead and look at all this, copy it, paste, run. And then we see that we got no errors, no type errors. We assign variables to the, notice that I did this different this time. I said x is equal to that function call. I did that because in this case, the function is returning something, right? If the function was not returning anything, x would be the none type. But because it's returning something, I can assign variables to its value. And then if I wanted to like double check and do something like throw in a string, I get my type error exception that I typed in. Okay.
Can you explain why is it type X, type of X?
Explain type of X.
Yeah.
So type is a built-in function in Python that tells you, so for example, type of 1 is integer. Type of 1.5 is float.
Oh, I see. Okay.
Yes.
Thank you.
It tells you the type of the object you're working on. I did like
Gotcha. Whether it's an integer, Boolean, etc.
Yeah, integer, Boolean, float, list, dictionary, NumPy array. It will tell you whatever the thing is, even functions, right? Okay. It's a way of checking to make sure that the types you're working with are how they should be. Okay, so I wasn't able to finish this, and we've run out of time, but I wasn't able to finish. But I would like to end saying that functions don't have to return things, they can mutate things. And we've seen that with the sort method. Methods are functions, right, on objects, on lists, right? So this is a type of function that will double each entry in a list and not return anything. See if there's no return statement. So for example, if I paste that there, and then maybe I do like, maybe like, I don't know, x is equal to 1, 2, 3, 4, 5, 6. And then I just call the list on x, and then I print out x. Notice that everything's been doubled, right? I didn't set this equal to a variable or anything. I just called it and it modified the entries there according to this, right? So we pass in x, and then everywhere inside here, we're doing things to the values in x. We don't return anything. Can someone tell me what happens if I do this?
Will return none.
Right, because this function by default returns nothing. Okay. And even if you can be like very specific about this, if you want to help, you can type something like that to emphasize to the reader that it returns nothing. So now, if you assign x to that function, it's going to be nothing. It's that simple. But if you just run it, it should modify X. Now, again, we've run out of time. I don't have time to talk about scope, but there are global and local scope. Global scope is basically all of the code outside of functions and code blocks. Local scope is confined to your code block. So when you instantiate a function, you're creating a new local scope that's contained in the function definition. And again, at the top of this notebook, there are these things here. All right, so I'm going to end the recording now.